Yes. Okay. That does make sense. So this, just a second, guys. So the law of cosines is a rule that allows you to find all the missing parts of a triangle. Where on the law of sines, if we look at the law of sines that we just did, say in this problem down here, in this problem here, we were able to apply the law of sines because we had an angle and the side opposite. And that's a requirement for law of sines. You have to have at least an angle and its opposite side. And if you do, you could find you could solve the triangle, which means finds all the missing parts, all the other sides and all the other angles. But
wouldn't you need another part of the proportion?
We just, on this problem 6?
Well, you would need another angle on the triangle.
No, well, yes, you need a third thing, but in order to use law of sines, you have to have an angle and its opposite side. You have to at least have that. When you don't have that criteria, you can't use the law of sines. You have to go with the law of cosines, which is more cumbersome. But the law of cosines, it's this formula, and it looks a little bit like the Pythagorean theorem. And I see squared. It doesn't matter. So let me write it down.
Oh, she knows.
Give me a minute and I'll explain what it means. Sorry. So you could write it any way you want with letters. In other words, it's a matter of your point of view. Okay, so let me explain what this means, guys. It's way too noisy in here. If you remember in geometry, the capital letters represent vertices, lowercase letters represent sides. And in general, they represent the side opposite the corresponding letters. So this would be side B, because it's opposite capital B. That's the relationship. The other thing is, when you get to Algebra 2, you actually have more background, and they'll go through, most Algebra 2 classes will spend some time deriving this formula. We're not going to do that. You're just going to learn how to use it today, which, you know, in geometry, we typically don't approach things that way, but in this situation, we're going to. So usually you'll see one formula, but all three of those formulas mean the same thing. It just means if you're looking for, say, side B, you would need to have, you know, some angle. You have to have angle B to do that. If you don't have an angle at all, then you've got to work backwards and solve for the angle. So I'm going to go through this process, and it could be a little cumbersome, but I want you to watch the process, and then we'll look at when you do have an angle versus when you don't have an angle. Okay? So in this case, if I wanted to find an angle, let's say I'm going to pick angle A. That means I would need to use this formula if I want to find angle A, because that's the only formula that has A in it, angle A in it. So I could say that A squared is 10 squared, and that's equal to B squared, which is 14 squared, plus C squared, which is 8 squared, minus 2 times 14 times 8 times the cosine of A. That's my first step. It's really important that you honor order of operations all the time. Mitchell.
would you figure the A squared, A, B, and C? How would you?
So I'm going to do samples before I answer homework questions.
No, I was just looking over the worksheet and I was seeing that you have letters A, B, and C, and those just happen to be the letters in the equation. How can you figure out which ones are A, B, and C in an actual?
It doesn't matter. So what matters is if you want A, I mean, it could be called anything. You would need to have the side opposite A alone. Because this corresponds to this angle. This angle is opposite that side. Do you get that? Yeah.
Is it minus that whole thing?
Well, I'm going to go through it. So you do have to do order of operations. So if you went through, give me some values, you guys.
100.
100, right? And this is
That's like 268, 9, 10, 12.
2,
196.
1.
Duh.
Sure? Cass has in a 6, right?
196.
Okay.
And
64. 64.
64.
Checking
Keep
notes.
going.
28. Minus 28.
Well, it's 28 times 8.
Oh, all right.
28 times 8, if you go to 56 and times it, it's 24, 224.
Okay. So this is really the trickiest part of the problem. When you solve this, add these together. What do you get?
260.
So you really have to employ your algebra skills. Okay, I'm gonna wait again. It's a little noisy. Lily.
Could you also just like square root both sides?
No. You can't actually, because it's not gonna, if you did that, then you'd have this whole variable in the square root. If you did this,
That's what this says we did.
well, it's different on the worksheet because they had angle A, but they were looking for the value over here.
Yeah, okay.
So no, the answer is no, not in this situation.
But in some situations you can do that.
We'll get there. Okay, this is the one that's most cumbersome because you actually have to work backwards, so to speak. So you don't have your variable alone yet. So the whole goal here is to isolate the variable. And so there's more work involved. So now I'm going to subtract 260 because this is one term. And you can't, when you solve, you undo order of operations in reverse order. So I can't undo that multiplication until I undo the additions and subtractions first. So I'm going to subtract here, and I get a negative 160 is equal to negative 224 cosine of A. Now, I'm going to divide by negative 224.
You get them?
And I get a positive number less than 1. So 160 divided by 224. This is 0.7142 approximately, right? Well, you should store this on your calculator, but you don't need to write it all down. Typically, you'll see 4 digits written down for trig values. And now you take the inverse cosine of it. And then you get 44.4 degrees. Now, that's an approximate value. So, in your triangle, this is where things, give me a minute, because I want to talk a little bit more. Sorry. In your triangle, that's angle A. That's this angle here, 44.4. But you would probably be asked most times to go to the whole degree. That being said, to finish the problem, you should use the stored value on your calculator.
Oh, and then you.
So you don't lose accuracy.
Wait, and then when they're done,
Or you can do like your
make sure
answer
all
book.
the angles together.
Yes, and then in the end, you make sure all the angles together make 180. So before I go on, do you understand how to find the angle when you only have 3 sides?
And at the end, at the last step, you put it inverse.
I did the inverse here. Right. So, Lily. Hey, you guys, I can't hear the question. What?
The notes you gave us, it has like a confusing, way of like.
The notes are from the book are so-so. I agree, but just in case I didn't, this wasn't enough, I think when you look back, the notes may help you, but if this helps you, I would just not use the notes. So, because here's what I want to say next, and I think everybody working ahead should stop and listen, because this is going to save you a lot of time if you haven't figured this out already. Sometimes people use the law of cosines over and over and over in one problem. I never do, right? I got a value of A. At that point, I go right to law of sines, because law of cosines is a lot of work. So now I can find angle B, because I could say the sine of A, which we now know is about 44 degrees, but I'm using the stored value. So I'm going to say the sine of 44, but it's more accurate on my calculator, over 10 is equal to the sine of B over 14. So I'm not going to do log cosines twice, ever. You do it once, and then you get what you need, and then you can go back to law of sines. Now, it's a personal choice. If you like doing this, well, go for it. But I wouldn't. So here, I would then just multiply 14 sine of 44 and divide by 10. So I'm going to do that, and when I do that, I get, I think I might have made a mistake. So let me type that again. You guys should probably type it in too, just to catch my work here. Okay, so when I do that, I get about 0.9797. And that's the sine of B. So now I'm going to take the inverse sine of that on my calculator, and I'll get B. And I get about 78.46. Okay, remember the first one was 44.4, so now I know if B is about 78.46. I'm going to round that down to 78. The 44.4 gets rounded to 44. I add those together, and I get 122 degrees. So my angle C has to be 58 degrees by the triangle sum theorem. It's going to all be approximate if they ask you to round to the whole number. So when you put that 58 in your triangle, you don't want to use B to calculate anything. So, like, if you had to find something else, you would always go back to your stored value. So that's the hardest part of law of cosines. The easier version, can I keep going?
Yeah, keep going.
So one other problem would be one like from your law of cosines worksheet, where I'm going to add a page in here. If you look at, say, problem 1, on your worksheet, you have this triangle, that looks roughly like this. And this is 16. This is U,
You could use the
P,
boson. You could
T.
use sine.
No, you can't.
No, Matt.
Okay,
Yeah, 'cause
so
A-
let's stop for a minute. Remember the requirement for the law of sine. No, it's still going. If you have to, if you want to use law of sines, I'm gonna wait. We only have the 39 degrees here. To use law of sines, you have to have the angle and the value of the side opposite.
yeah.
So if you have what we would say is side, angle, side situation, you can't use law of sines. You have to use law of cosines. But this version's easier because you at least have one angle. And so what happens is, if you want to find t, you would say t squared is equal to
256 plus 441.
21 squared plus 16 squared minus 2 times 21 times 16 cosine of 39. So look and see what I did there.
Instead of cosine.
Order of operations is all going to be.
This is where you get one big number and take the square root.
Oh my.
That's just like you gotta really think about your calculator.
You do. You really have to think about your calculator use. So what's 21 squared? 21 squared?
Oh, no, 441.
Thank you.
I did it 16 squared plus 5.
That's fine. 441 plus 256 minus what?
32.
5, no, I didn't.
Oh, 32 times 21. 32 times 21.
Dude, that in your head. I did it all together and.
672. That's 39.
So when I add this together, 441 plus 256, this is 697 minus, and then 672 times cosine of 39 is about 522.
I stored that.
Yeah, and you can store it, and then
That's really big.
you get about 174. That's not a decimal. 174.75, and that's t squared. Yeah, I rounded it. It was 757. So I'm going to take the square root
And it's 13.21.
of that, and I get 13.2.
Wait,
That's
John's
a lot of work for a little tiny
Okay,
size.
from that point, you guys,
So
okay, I'm going to wait. A little noisy. From that point, to find the other angles, use law of sines. Don't use law of cosines twice. I wouldn't. I mean, you can. I just wouldn't. Lily, what was your question? Okay, Connor.
Oh, did you just have to memorize that equation?
Yep. Memorize it because it's never going away. Ever. I mean, basically, you guys, it's not that hard. It starts out like Pythagorean theorem, right?
What if we just.
Knock yourself.
Okay, I'm going to stop that and post it.